I will also ask Shane again to come to our stage and present Thailand Internet stat. So welcome Shane again.
Good afternoon again. Do I get 45 minutes for this?
Will? Sure. Okay.
I'm just kidding. I only really need 10 minutes, hopefully, just to present Thailand Internet stats, really mostly from APNIC's point of view, using APNIC labs and statistics that we have available at APNIC. So APNIC, as you know, is the regional internet registry for the Asia-Pacific region. Our vision is simple. It's a global, open, stable, and secure internet, which I think we share with all of you. This is actually an older version of my slide. So I might skip some of the stuff, so I'll just go directly into some of the more important bits that is in my latest slide. Anyway, firstly, resource delegations for V4, V6, and AS numbers. For Thailand, we have 1,342 delegations, and that has a total of 39,000/24 prefixes, which is good. Like, we have a lot of V4 prefixes delegated to Thailand. And as you can see, only it has sort of like flattened out towards 2012 forwards because of IPv4 exhaustion. When it comes to IPv6, we have delegated 257 delegations, and that accounts to about 153/32 prefixes. Most of that really still increasing, so we're getting a number of IPv6 requests here and there. Now, when it comes to AS numbers, we have 832 ASNs delegated to Thailand. This shows a healthy and diverse internet ecosystem in Thailand. Mainly, of course, we have networks that are like ISPs, enterprises, and all that, all becoming part of the internet global routing. So when it comes to, this is actually very old. All right, I do have some more stats actually that shows the comparison for V6 deployments in Southeast Asia, because it would be nice to compare Thailand with the rest of its neighbors. For the V6 deployment, we now have reached more than 50% capability worldwide, and Southeast Asia, if I'm not mistaken, is also around the 50-60% mark. Thailand is about the same, 50.9% capable, and a little more than half, I think it's now 50 point something preferred, so that means half of the traffic in Thailand now prefers IPv6. If you can see from the graph, majority of the increase in the IPv6 deployment percentage in Thailand happened since 2016. 2016 is when AIS, I believe, deployed dual stack, and then 3BB also deployed around 2020. True has also deployed their IPv6. So from 2016 to around 2021, 2022, you see a really big growth in IPv6 deployment. Since then, it has been increasing still, not as much as the last 5 or 6 years, but still growing steadily. One thing worth noting as well with this is you can see some of the enterprise networks, a lot of universities, some government units as well, have about 50 to 70% deployment rate. Obviously, overall, it doesn't have a big impact in the capability for the whole of Thailand, but it is good to see that, like, for smaller players, they are also deploying IPv6. Now, when it comes to ROA coverage for Thailand, we have 89%. Hopefully, this is the latest figure. I think this is sort of correct, and about 64% IPv6. Now, I wanted to just like quickly compare that to our neighbors. A majority of the economies or the countries in Southeast Asia have pretty good numbers when it comes to ROA deployment. Actually, comparing to the Asia and even the global average, we are about 92.2%, if I'm not mistaken. And that is impressive because the global average is, I think, just around 50 to 60% as well. So that's a huge difference. So we're kind of like ahead when it comes to this. The leaders, if I'm not mistaken, are Vietnam, Malaysia, and the Philippines. So there's like 98, 99%. But once you get to that level, really, it's now a moving target because you will have some delegations returning IP addresses and things like that happening. So it's very difficult to then get to fully 100%. But Thailand average is already impressive in itself. One thing to maybe note here, whoops, I feel like it's moving on its own. Oh, did you change it? There you go. All right, sorry about that. So, ROA, as you can see here again, Thailand is just under 90% IPv4 and a bit over 60% IPv6. One thing I guess that you can see potential improvement here is for IPv6. When you're deploying IPv6, announcing your IPv6 route, it would be good to also then consider as part of the process to create ROAS for your IPv6 box. Now, what about route origin validation? So both Anurag and I have talked a little bit about origin validation during the previous talk. Notice here that Southeast Asia is at under 14%. Considering how impressive we were with ROA, ROV shows a very different story. So we need to, collectively work on this part. The global average is just under 30%. Still not that high, but there is room to improve for Southeast Asia here. Myanmar is on top of this, so they're kind of like an outlier with over 50%. All the rest are just about 20 to 30%. Unfortunately, in this case, you will see that Thailand is only 0.4% ROV, just above Brunei, who's really not doing anything in the RPKI space. So I think you can do better than this. So I would like to pose a challenge for this group to try and see whether there is a ways that we can support each other, try to understand what the community needs, what are the concerns around ROV, so we can move forward and improve these statistics. I'll skip this because I've talked about ROA. Another thing to look at is very specific ROA states: valid, not found, and invalid. So just looking at the percentages, IPv4, 10% of routes don't have ROA coverage yet. And with IPv6, that's even more. That's 1/3 of your V6 routes don't have ROA coverage for them yet. Now, when it comes to invalid, we're doing quite well. 0.1% invalid in IPv4. Well, it's showing 0% for IPv6, but that's not exactly zero. There's like very few, but considering the whole IPv6 space, it's really negligible. So here's a bit more stats around this. IPv4, there's about 373 invalids. That's not much, but we can fix that. Majority of the cases is actually due to invalid max length. So it's an easy fix. Hopefully, if you can look at it, we can, fix this one. For IPv6, only 32 with invalid max length, and 2 for both invalid AS and max length. So if you can look at your prefixes, your ROAS, see whether there's like invalids, please try and fix them. At this point, probably if you're not implementing RPKI, probably doesn't have an impact to you, but the more that it is being used, then you can see that it has a significant impact, because invalid showing here, if you did not intend for this to happen, means that your prefixes will be dropped and reachability will become an issue, right? So for ROV, this is just a list of the networks in Thailand. The what you can see here, obviously, is none of the major ISPs have implemented ROV yet. So again, a challenge for all of you to improve this. So do you need assistance? We can help. APNIC obviously supports internet development in the region. We do a lot of training and capacity building. We do direct technical assistance. If you do need support on IPv6, deployment, planning, RPKI, ROA, fixing ROAs and things like that, please do reach out to us. And that's it. Kapag ka.
Any question? So may I have one question, Chen? May I have one question? So we have seen that for Thailand, for ROV, obviously the deployment is quite really low, right? Since we have many operators here, so what is your general recommendation to the operator how to raise the ROV deployment in Thailand?
Drop invalids. So, well, I guess there's a few more steps around it, but by the end of it, obviously, your goal is to drop invalids round. So firstly, you need to have ROAS. You're already doing well on that. Nextly, implement RPKI, apply policies. If you're not ready to drop invalids yet, then please look at implementing, like say, policies wherein the invalids are less preferred, and at some point, you do need to drop invalids, either on the IXS or the major ISPs, I think would be a good start.
All right, thank you.
Thank you.
Okay, so that's all for lightning talk. We end the session a bit earlier.